Have you ever written Executors.newFixedThreadPool 10 and wondered how it actually works? Today we'll build the core of a thread pool from scratch, using a blocking queue, worker threads, and wait/notify. You'll never look at Executor Service the same way again. The queue is the heart of the pool. enqueue adds a task and wakes one waiting worker via notify. dequeue blocks if the queue is empty, using wait until a task arrives or shutdown interrupts it. This is classic producer-consumer synchronization, exactly how blocking queue works under the hood. Each worker loops until the pool is shut down and the queue is empty. It pulls a task from the queue and runs it. If the queue is interrupted, which happens during shutdown, the worker rechecks the stop condition. This simple loop is the blueprint of every thread pool worker. The constructor creates and starts all worker threads immediately. Submit guards against adding tasks after shutdown and pushes the task onto the queue. This mirrors threadpool executor.execute. Shutdown sets a flag and interrupts all workers stuck in the queue. A wait termination joins each worker thread, waiting up to the remaining timeout. If any worker still runs after the deadline, it returns false. This is exactly how ExecutorService.await termination behaves. We submit 5 tasks to a pool of 3 workers. Only 3 run immediately, the other 2 queue up. Each task prints its start and end with the worker thread name. After a short wait we shut down and confirm termination. You can see the 3 worker threads reuse. After task 0 completes, worker 0 picks up task 3, and worker 1 picks up task 4. The output proves the pool is working correctly. You've just built the beating heart of every Java thread pool. This core pattern, a blocking queue and a fixed number of worker threads, powers tens of thousands of production servers. Now you understand Executor Service from the inside out, ready to tune thread counts, debug starvation, or even build a custom pool.